Today we are learning quadratic equations, quadratic functions. So what is a quadratic function? Quadratic function is where you have a polynomial function and its highest order is to the power of 2. So it can be written as fx equals to ax to the power of 2 plus bx plus c. That is one of the general way to write it. You can also write it in the form of a perfect square form, ax minus h squared plus k. This may be one of the two of the ways that you may have seen quadratic equations has been displayed or expressed. A value pretty much helps to determine the directions and the width of the parabola. You may have heard of when a is bigger than 0, you will have a smiling face. When a is smaller than 0, you will have a frowning face. B helps to influence the positions of the parabola, and C is the y-intercept where the graph crosses the y-axis. An example of a quadratic equation is x squared plus 2x plus 1. Moving on, because this is a quadratic equation, you will have a turning point. A turning point is sometimes also known as the minimum point or the maximum point. So, as we mentioned earlier, if in the equation of y equals to ax squared plus bx plus c, if a is bigger than 0, and that means the parabola is having it open upwards, and so the vertex or the minimum point is a minimum. And on the other hand, when a is smaller than 0, you will have a vertex to be the maximum. Now there are two ways to find this point of stationary, the turning point. One of the way is to utilize completing the square. Another way is to use differentiation. We are going to demonstrate both of the ways. So if you try to use completing the square, when y equals to x squared plus 4x plus 5, all you have to do is just to make it compatible into this particular form. X plus b over 2 squared plus c. So you have to make sure that there is a b over 2 over here. And of course, once you have added that b over 2, you have to minus the b over 2 squared because that is generated from the perfect square expansion. So in this particular case, y equals to x plus b over 2, which is 2 squared minus 2 squared plus 5. So y equals to x plus 2 squared minus 4 plus 5. Y equals to x plus 2 perfect square plus 1. And in this case, you will then be able to determine the value of the vertex. The values of the vertex, which is at h equals to negative 2, at k equals to positive 1, and that's the reason why you will see it says vertex is located at negative 2 and 1. You can also use differentiation. So for an example, y equals to x squared plus 4x plus 5, you can differentiate it dy dx, and so it gets 2x plus 4. You can make this dy dx equals to 0 because you understand that at the turning point, its gradient is always 0. Gradient is always 0 at any turning point, be it the point of maximum, be it the minimum point, it works the same. So when dy dx equals to 0, 2x plus 4 equals to 0, you will be able to solve x equals to negative 2, substitute back into the equation, you will get y equals to positive 1. The second method, also allows us to achieve the same results. We have to talk about the discriminant and root because it is very important to understand that when you have a quadratic equation, you may encounter one of the following three scenarios where it will not touch the x-axis, it will cross the x-axis, it will only meet or touch the x-axis. So when it is not touching the x-axis, it means that there is no solutions. Solutions simply means the intersections with the x-axis. So as you can see, when it is not touching the x-axis, there's no solutions. When it is crossing the x-axis, it has two solutions, two real solutions, the one that we can see. When it is only meeting the x-axis once, it has one real solution. And this is when we have discriminant smaller than 0, discriminant bigger than 0, and discriminant equals to 0. And what is discriminant? Discriminant is from the formula of b squared minus 4ac. Now, a quick example that we can see from here is also demonstrated on this particular page. So on this particular page, you can see that when y equals to x squared minus 5x plus 6, a equals to 1, b equals to negative 5, c equals to 6, you will be able to determine its discriminant, and it's already determined, given to you that discriminant equals to 1, and therefore you will come to the conclusion that there are two real roots, there are two real solutions. Roots means solutions. Moving on to the next page. Now we are talking about solving those solutions. We know that certain equations, certain quadratic equation has one solution, two solutions. Now we would like to know where are them. So we are going to have this equation y equals x squared minus 5x plus 6, as we have shared earlier. Solution means the x-intercept. So when y equals to 0, x squared minus 5x plus 6 supposed to be equal to 0. Using one of the three different methods, it can be solved using factorizations, completing the square, or quadratic formula. Quadratic formula looks like negative b squared minus 4ac divided by 2a. You may have heard of it before. And factorizations is basically using cross multiplications. So in this case, we can have both of these to be negative, and so you will have x minus 3, x minus 2, which ended up to be negative 5x in the middle. So using one of the three different methods, you will still get the same answer of x equals to 2, x equals to 3. So these particular quadratic equations will cross the x-axis at these two particular spots of x equals to 2 and x equals to 3. We also would like to talk about how we can graph the quadratic equations. For us to draw the graph, we have to know some of these few things. For example, you have to know the turning point, which is also the vertex. You need to know also the x-intercepts as well as the y-intercept. Usually, these are the three things that are important for a drawing. So y equals to x squared minus 4x plus 3. Let us determine all these three items. Number one, the turning point. The turning point can be determined by completing the square or differentiation, as we have shown you earlier. So in this case, we use completing the square. Y equals to x minus 2 to the power of 2 minus 2 to the power of 2 plus 3. Y equals to x minus 2 to the power of 2 minus 1. So in this particular case, you will have turning point at 2 and negative 1. Number 2, x-intercept. X-intercept is when y equals to 0. So again, y equals to 0 means x squared minus 4x plus 3 equals to 0. Use cross multiplications, you'll be able to get minus minus x minus 3, x minus 1 equals to 0, x equals to 1, and x equals to 3. Last but not least, you'll need to figure out y-intercept, or when x equals to 0. So again, this is rather straightforward. When x equals to 0, y equals to 3. So 0 and 3 are going to be the y-intercept. Combining all these informations together, this is x-axis, that is y-axis. This is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So 2 and negative 1 is roughly here. This is the turning point, and you will cross it at x equals to 1. s equals to 3, and then 0, 3 is y-intercept. So connect all these informations together. This y equals to s squared minus 4x plus 3 will then be able to draw. Quadratic inequalities is another important part where we have to find a section for it satisfies the inequation that has been determined. So for example, in this case, if you were asked to solve a question like this, the general solutions remains roughly the same. The only exception is you are now first assume that it is equivalent to 0. Then you will need to draw the number line where you will have to start from positive, negative, and positive for every quadratic equation. For every quadratic equation, this number line is always the same and it remains correct. So you will have the positive regions. You will choose the positive region when you see bigger or bigger equal. You will choose the negative region when you see smaller or smaller equal. Right, so that is the only difference it makes. So solving these questions, x squared minus 5x plus 6, first of all, we equate it to be 0 because we would like to determine the x-intercepts. So x minus 3, x minus 2 equals to 0, x equals to 2, x equals to 3. Then we can draw the number line. This is plus, minus, plus. So in this case, we see bigger, so we will choose the positive region. Therefore, the region that you will satisfy is when x is smaller than 2, when x is smaller than 2, or x is bigger than 3, right? Because these are the two regions that these two positive regions sit at. We can also talk about quadratic equations as well as tangent. Sometimes we would like to determine if a line will not touch it, if a line will cross a particular curve, or if a line will just touch at a particular curve at one point of intersections, no point of intersections, 2 point of intersections. We would like to determine which one of this is the case. For us to determine it, one of the quicker way is actually to use the discriminant test. Right? So for us to have 2 intersections, you will have discriminant test to be bigger than 0. If you would like to only have 1 intersection, discriminant test is equal to 0, no point of intersection, and that will mean your discriminant test must be smaller than 0. A quick example, if you have a line y equals to 2x plus 1 and equation y equals to x squared plus 3x plus 2, what you need to do is you need to transform this into a new quadratic equation by equating the first y1 and the second y2 to be the same. So you have 2x plus 1 equals to x squared plus 3x plus 2. You are going to form this new quadratic equation of x squared plus x plus 1 equals to 0. From here, you will then be able to tell the values of a, b, and c. And then you put it into the discriminant test, b squared minus 4ac. So the discriminant test 1 squared minus 4 times 1 times 1. Discriminant test equals to negative 3. And it will mean this particular line y equals to 2x plus 1 will not touch because it satisfies the middle graph, so they will not touch at all. These are some of the practice problems, so I'm going to do some of this and then you can practice more in the extra reading materials. Find the minimum value y equals to x squared minus 4x plus 5. Again, we can use the completing the square. Y equals to x minus 2 square minus 2 square plus 5. Y equals to x minus 2 square plus 1. So the vertex is going to be 2 and positive 1. So this is the minimum value for this particular question. Solve using quadratic formula for the second question. X squared minus 3x minus 4 equals to 0. A equals to 1, B equals to negative 3, C equals to negative 4. So x equals to negative b plus or minus b squared minus 4ac divided by 2a. So x equals to positive 3 plus or minus 25, 2. So x is 5, 2. X is minus 5, 2. X is going to be 4. X is going to be negative 1. So these are the two values. In order to get the graph of these particular equations, we have to determine three things. Number one is the x-intercept, y-intercept, as well as the turning point. So y equals to negative x squared plus 6x minus 8. X-intercept is when y equals to 0. So 0 equals to negative x squared plus 6x minus 8, or you can rewrite this as x squared minus 6x plus 8 equals to 0. X, 4 and 2, negative, negative. You will then be able to get x minus 4, x minus 2 equals to 0, or x equals to 2 and x equals to 4 to be the x-intercept. Y-intercept is when x equals to 0. When x equals to 0, y equals to negative 8. As simple as that to be. Turning point. The third part of it is to actually determine the turning point. And in this case, we can determine turning point using either of the two methods we have learned. In this case, we are going to use differentiations. So dy dx is going to be negative 2x plus 6. When dy dx equals to 0, you will then have x equals to positive 3. Substitute the values of 3 into the equations. You'll get negative 9, 18, 8. So you'll get positive 1. So combine all these informations together. This is negative 0, negative 8, 2, 0, 4, 0, 3, 1. You'll then be able to draw the curve and then label it as negative x squared plus 6x plus 8. At the end of the day, these are some of the key takeaways. Do not forget, read the additional reading material, do the quiz. Thank you very much for listening.